Question number 6 says, a 5 cubic meter tank of compressed helium gas has an absolute pressure of 4 kilopascals at a temperature of 27 degrees Celsius. What is the mass of the helium in the tank? And it tells you that 1 kilomole of helium weighs 4 kilograms. So, initially, we have a volume of 5 meters cubed. We have a pressure of 4 kilopascals. Now this is an absolute pressure. This will be important in just a minute. We have a temperature of 27 degrees Celsius. We have a molar mass of 1 kilomole of helium weighs 4 kilograms. So it's saying the molar mass is equal to 4 kilograms per kilomole. So, right off the bat, the first thing that I think of is ideal gas. If you've taken chemistry, this might be a little more apparent, but if we have pressures, volumes, we need to find a mass and molar mass, we need to use this equation, which says, it's called the ideal gas law. And it says, pressure times volume is equal to number of moles times the universal gas constant times temperature. So, pressure is always in pascals. Volume is equal to cubic meters. N equals the number of moles of substance, which is equal to the mass over the molar mass. R is the universal gas constant. If you look at the top of your exam, it tells you that the universal gas constant is 8,314 joules per kilomole Kelvin. And the last thing is temperature. For an ideal gas, temperature always is in units of Kelvin. So this can cross out in the universal gas constant. So, anytime you see an ideal gas law question, make sure, I know if you've taken chemistry, you might see this in atmospheres, you might see volume in liters. For physics, they look at everything different. Make sure you use this 8,314, not 0.0826, because that is for chemistry and you'll most likely get the wrong answer. So, really quick, we want to talk about pressure. It tells us in the problem that this is the absolute pressure. And we know the formula for absolute pressure is equal to pressure in the atmosphere plus your external pressure. So atmospheric pressure is 100 kilopascals. In ours, it already gave us the absolute pressure, which was perfect. It told us it was 4 kilopascals. But just for any reasoning, if you had to go down a depth and do pressure is equal to rho GH that we learned before, this would give you the pressure underwater in pascals. You would plug that here and then add another 100 kilopascals. Also, if this was the gauge pressure, this could be the external or the gauge pressure. So be very careful. If it says gauge pressure, you need to add this 100 kilopascals. And make sure you're adding kilopascals to kilopascals, not kilopascals to pascals. So here, we already know it's 4 kilopascals. So that's the first thing we're going to do in our equation. So we're going to say 4 kilopascals is equal to 4,000 pascals. We have a volume of 5 meters cubed, and that's already in cubic meters, but be careful if he has it in cubic centimeters, you're going to have to convert it to meters cubed. we know that we're looking for a mass. And we already said that N is equal to mass over the molar mass. So, mass is what we're looking for, and the molar mass is 4 kilograms per kilomole. Plug in R, which is 8,314 joules per kilomole times Kelvin, and temperature has to be in Kelvin. You see here that he gave you it as 27 degrees Celsius. So to get to Kelvin, we have to do 27 plus 273, which is a nice round number of 300 Kelvin. So we can go ahead and multiply 4,000 times 5 times the 4 kilograms divided by 8,314 and divide that again by 300, and we get 0.032 kilograms, roughly. There might be different sig figs on your calculator. And we see that answer choice A is 33 grams. So, all I did here was I multiplied the pressure by the volume, multiplied it by the molar mass, divided it by the universal gas constant R, and then divided it by temperature, and you solve for the mass, which is 33 grams. Remember, the mass is always going to come out in kilograms because your molar mass is in terms of kilograms, and so is your joules. So this is how you work an ideal gas law problem. Make sure you have this equation on your formula sheet. It's very important.